Hello, grade 10 students. It's your math boy here. Today, we're gonna be doing the application of derivatives, which we're gonna be digging into finding the gradients, finding the x values, and finding the stationary points in which derivatives will be applied. So, let's start application of derivatives. Okay, so you can be given the equation right here. If fx is equal to 2x squared minus 3x cubed, and we're told find the gradient if x is equal to 1. Estimate the gradient. So we have to find the derivative of this function if x is equal to 1. Is equal to 2 times 2x minus 3 times 3 x 3 minus 1 2 minus 1. Then our derivative here will be 4x minus 9x squared. Now we substitute, we plug in 1 into our new equation. So it'll be f dash x is equal to 4 times 1 minus 9 times 1 squared. Then f dash x is equal to 4, 9. And our gradient is equal to negative 5 is our gradient. Or you can be told the other way around. You're given the gradient, but just find the x value. For example, if you're given y is equal to x squared minus 4x plus 3. And if you're told if the gradient is negative 1, and you can be told so find the x value. Okay, so here we begin. We differentiate this function, it will be 2x minus 4 is equal to negative 1. Y dash is equal to 2x negative 1 plus 4. Y is 2x is equal to 3 over 2. Then our x value is equal to 3 over 2. So we're already done with finding the gradients and x value. Right now, we're gonna find this stationary points and turning stationary points, which are the turning points of the curve. So let's start with a simple quadratic equation. You can be given fx is equal to x squared minus 4x plus 1, and you're told find the turning points. So let's first differentiate this function. It will be 2x minus 4, and we set the equivalent value to 0. So f of x is equal to 2x 4, and x is equal to 2. So In our coordinates, 2 is the x value. Now, if you're told to find the y value, we substitute this 2 into our original equation right here. So it will be 2 squared minus 4 times 2 plus 1. 2 squared is 4 minus 8 plus 1. And our y value is equal to negative 3. So the turning points are 2 and negative 3. Now, this is our turning point, but you can also be asked in a test to describe the nature of both of these turning points. It's as simple as that. So we substitute we have to find the number greater than 2, which is 5, and a number less than 2, which is 0. So we substitute 0 and 5 into our differentiated equation. Okay, so these are our values right here. Okay, 0 minus 4 is 4, negative 4. And 10 minus 4 is 6. So we go down and we go up. Sorry, my curve is kind of messy. So after going down and up, the turning points here are minimum points. Now I want to give a cubic function because the cubic function also has a different way of starting, not like the quadratic function. So our cubic function right here, fx is equals to x cubed minus 6x squared plus 2. So we differentiate this equation f dash x is equal to 3x squared minus 12x. Because we have both unlike terms on one side, we factor out the equation. So the common factor here is 3x. So it will be 3x x minus 4 is equal to 0. Then we solve the value of x for each. So 3x is equal to 0 and x is equal to 0. X minus 4 is equal to 0 and x is equal to 4. So we're told we want to find the coordinates of these stationary points because there are two stationary points right here. So in order to find the coordinates for each, we have to do first write 0, y, and 4, y first, which is a and b. So we substitute 0 and 4 into our original equation right here. So it will be 0 cubed minus 6, 0 square plus 2. And right here will be 4 cubed minus 6 times 4 square plus 2. And our y values here will be 2 and negative 30. So both a and b coordinates will be 0 and 2 and 4 and negative 30. So now let's classify the nature of these turning points. So we write 0 and 4 on our number line first. Now we look for a number less than 0, which is negative 5. A number more than 0 is 2. And a number less than 4 is 2. And then so The number which is greater than 4 is 5. So we substitute these three values in our differentiated function, -5, 2, and 5. Okay, so after I write down all the equations, now we just need to find the value of each. So the first value is 135, which is a positive value. Our next value is -12, and our final value is 15. So we have two positive values and one negative value. So from 5, we go up, down, up again. So 0 is the maximum value and 4 is the minimum value. So A is maximum and 4 is minimum. So guys, thank you very much for watching my video. I hope you really loved how we apply derivatives and other perspectives. And if you did, please like and subscribe to my channel in order to watch more of my math tutorials. I'll see you guys again soon for another math tutorial, and thanks for watching. And of course, good luck.